Dear students, today topic is dynamic programming core concepts. In that, we need to discuss two methods, memoization and tabulation method. Then before going to the memoization and tabulation method, first we'll discuss the dynamic programming. The dynamic programming is an algorithmic technique used to solve the complex problems by breaking them into the smaller overlapping subprograms and strong their results to avoid the repeated computations. Then here, the dynamic programming main purpose is to avoid the repeated computations. Means we need to no need to solve again and again. If you are solving a problem one time, means that is correct. No need to solve again and again. The dynamic programming is especially useful when the same subproblems are solved multiple times. The problem can be divided into optimal structures. Then here the core principles of dynamic programming. The first one is optimal substructure. Second one is overlapping subproblem. Then here, why dynamic programming means reducing the time complexity, avoid the redundant calculations, convert exponent time solution into polynomial time. Then here, when recursion will be occurred, then what happened? The time complexity will be increased. If recursion is occurred, the time complexity will be increased. Recursion. Then many problems we are using recursion. Okay. Then recursion means self-calling, calling itself, calling again and again. Then dynamic programming, the main purpose is to avoid the repetitions. Then the repetitions will become, then what happened? The time complexity will become exponent values, very high values. We cannot define these exponent values like 2 to the power of n, 3 to the power of n, and so on, k to the power of n. Then if you are using dynamic programming, these exponent values will be reduced. Then we'll get the polynomial time. The polynomial time means it's maybe order of 1, order of root n, order of n, order of n square, n cube, n log n, like that, n log n. Means using this dynamic programming, we need to reduce the time complexity and we need to avoid the repetition. Okay. Then next one is optimal substructure. A problem has optimal substructure if it is optimal solution can be constructed from optimal solution of its subproblem. Then from that subproblems, we need to find the optimal solutions. Then the practical examples of dynamic programming. One is Fibonacci sequence. Second one is knapsack problem. Third one is shortest path. Then today's topic will discuss about Fibonacci sequence and remaining two topics, knapsack problem and shortest path, we'll discuss later. Then coming to the Fibonacci sequence, this is everyone knows Fibonacci sequence. Okay, this is the Fibonacci sequence. When we are using recursion, what happening here? Then you can see here what happening. When we are using Fibonacci sequence, you can see here Fab2. The Fab2 is what is on the value of Fab2? Then Fab2 is coming from Fab1 and Fab0. Means Fab2 is coming from Fab1 and Fab0. Fab0. Then there is a values of Fab0, it is 0, and there is a value of Fab1, it is 1. Then what is an Fab2? Then Fab2 value is what? 1. It's already calculated. But here you can see this example in this recursion. Here we already calculated Fab2 value. Okay. Then again here we need to calculate Fab2. Again we need to calculate Fab2 here. Means many times here repeated. Similarly, here we need to calculate. Here also we need to calculate Fab3. Here what is happening? Repetition. You have already Fab2 value. Just you can use the Fab2 value. That's it. You can use the Fab2 value. That is the value is 1. Then if you have calculated Fab3, just you can use the value. No need to calculate again. Then this is the main drawback in recursion. Then using the dynamic programming, we can solve this problem. Okay, just we'll see this example. Then Fab5 calls Fab4 and Fab3. Means Fab5 is called Fab3. Then Fab4 again calls Fab3. A repetition. Then here you can see example Fab5 calls Fab4 and Fab3. Fab4 again calls the Fab3. Here the repetition will become. For solving this problem, we are using dynamic programming. In the dynamic programming, we have two methods. One is memoization method. Second one is tabulation method. Then in memoization method, we have the recursions. And tabulation method, we are using non-recursion. Then memoization is top-down approach. Tabulation is a bottom-up approach. Then first we'll see the memoization concept. Next we'll move to the tabulation. Then here, when we are using recursion, then what happened? It will be shifted to exponential value. The dynamic programming always it will be linear programming. Okay, then first we'll see the memoization that you will understand. Then memoization is an optimization technique primarily used to enhance the performance of algorithms by storing the results of expensive function calls, reusing them when the same inputs occurs again. Means this memoization concept is coming from memorandum. Then what is the purpose? The purpose is if you are already calculated some results that will be stored. Then again, when the same function is coming, just we need to use that values. No need to calculate again. Then why memoization used? Memoization is a specific form of caching that is used to dynamic programming. The purpose is caching is to improve the performance of our programs. The main thing is we need to improve the performance of our programs and keep data accessible that can be used later. Basically stores the previously calculated result. Whatever the result will be calculated, that will be stored. Okay. Then whatever the calculated results, that we can reuse the stored result for the same subproblems. Way to use the memoization concept. Memoization is useful is situation where previously calculated results can be reused. Just for understanding, we'll see the memoization concept. It's purely top-down approach. The tabulation is a bottom-up approach. Okay. Then here we are using recursive function calls. That's why the stack is required. Then what is an advantages and disadvantages? Then before going to the advantages and disadvantages, just we'll see the one problem, then we'll return back. This is the, we need to find the Fibonacci's value of phi. The file here, this is the Fibonacci sequence. Everyone knows the Fibonacci sequence. Then what is an Fibonacci sequence value? Then first we have the initial value, fib 0 and fib 1. 0 value is 0. The 1 value is what? 1. Then what about F2? F2 is F1 plus F0. Then what is an F1 value? The F1 value is 1, F0 value is 0. Then what is an F2? 1. 1 you got. Then similarly, what is an F3? What is an F3? That is F2 plus F1. Okay. Then here you can see this is F5. F5 is divided into, it's recursively called f of n is equal to f of n minus 1 plus f of n minus 2. Means f of phi is calling the f of n minus 1 means f of 4 and f of 3. Then f of 4 is calling f of 3 and f of 2. Then f of 3 is calling f of 2 and f of 1. Then f of 2 is calling f of 1 and f of 0. Okay. Then here f of 2 again calling f of 1 and f of 0. Here f of 3 is calling f of 2 and f of 1. Means what is a basic structure of this one? Just this one is f5. This will be calling f4 and this will be f3. Again f4, f3 and this is f2. Then what is an f3? f1 and this is f2 and f1. And what is an f2? f1 and f3. Then what is an f2? f1 and f0. Then what is an f3? f2 and f1. Then what is an f2? f1 and 3. Okay. This is a normal of Fibonacci sequence. Okay, this is a top-down approach. Now we are in f5. And it will be goes to f4, then f3, then f2. Then we know the value f of 0. This value is 0. This value is 1. 0 plus 1 value is 2. Here f of 1. F of 1 is already calculated. Just you can use the value. No need to calculate again. Then this is 1. Then 2 plus 1. What is the value? 3. F of 3 is value 3. Means f of 3 value is what? 3. Then next one is we need to calculate F4. And if we want to calculate F4, then we need to calculate F3 plus F2. Then here goes to F2. Then here F2 we have value. No need to calculate this F1 and F0. Means these steps will be reduced using memoization concept. Then we have already value, use that value 2. Now what is the value 3 plus 2? 5. Then similarly F3. 3 also have value. Then what is an F3 value is 3. No need to calculate these all steps. We need to reduce these all steps using dynamic programming. 5 plus 3 is what? 8. Then what is in a sequence? 0, 1, 1, 2, 3, 5, 8. Okay. And here some steps are reduced. Here some steps are reduced. Why it is reduced? This is a repeated. We have already values of subproblems. No need to again calculate. Okay. Here this is an advantage of memoization concept. Now we can see here. This is hope you are understanding. F of n is equal to f of n minus 1 plus f of n minus 2. Here, we need to reduce the exponent value to polynomial value. Then if all things will be repeated means you will get the exponent value. Here many are reduced. Many self-calling we need to avoid it. We no need to calculate again and again. That's why the time complexity is reduced. Then what is an advantages of memoization concept? Reduce the time complexity. Reduce the time complexity. Then efficient for recursive problems. Yes, recursive problems it's more efficient. The recursive self-calling increase the time complexity. If you are using memoization concept and dynamic programming, definitely it's work more efficient. Computes only required subproblems. Whatever the which subproblem we need to calculate, we are calculated only those subproblems. Improve the performance significantly. Yes, we need to definitely increase the performance. Simple to implement. The implementation also very simple. It won't take much code. This is an advantages of memoization. Then whatever the disadvantages of memoization? Then required extra memory usage. Why extra memory usage? You can see here. This is these are we are avoiding, but memory we are using for F1, F0, F2, F1, F0. This we are avoided, but memory is what extra usage. Then recursion overhead. Then we have the recursions are more that will be overhead. Slower than iterative DP in practice. They're a little bit slow. Not suitable for all problems. Then we cannot say this is best for all. We will get the optimal solution, but we cannot say this is suitable for all problems. Memory management is a complexity because every function we need to use some separate memories. Okay, this is the concept of memoization. Then we'll see the tabulation mechanism. Then tabulation technique is very simple compared to memoization. You can see here for tabulation, there is no recursion. Just we are using the array concepts. Here, just we are using the arrays. A loop is enough for implementing this tabulation mechanism. There we have, this is the array. This is the array. Then we have f of 0, f of 1, f of 2, f of 3, f of 4, f of 5. Then we have initially we can store the values zeros and ones. We are not using recursion. Then this is non-recursive. Then f of 0 value is 0, f of 1 value is 1. Then for loop will be running from 2 to n. Then n is here 5, n is equal to here 5. Then 2 to 5. F of I. What is an f of I? F of I means 2. F of 2 is equal to f of I minus 1. What is an I minus 1? 2 minus 1 means 1. Then f of I minus 2, f of 0. Then what is the value of f of 1 plus f of 0? The value of f of 1 is 1, f of 0 is 0. Then 1 plus 0, 1. Then you will get 1. I plus plus, I plus plus. Then f of 3. F of 3 is equal to what? F of 2 plus f of 1. Then you have already the value of f of 2. And what is the value of f of 2? This is 1. Then you have value of f of 1. What is the value of f of 1? 1. Then 1 plus 1, 2. Then f of 3 is equal to 2. Similarly, we have the value of f of 4. F of 4 is equal to f of I minus 1. F of I minus 1 means 4 minus 1 plus f of I minus 2, 4 minus 2. Then 4 minus 1 means f of 3 and f of 2. Then what is the value of f of 3? This is 2 plus f of 2. F of 2 value is what? 1. Then 2 plus 1 is 3. Then f of 4 value is 3. Then coming to f of 5, then this is f of 5 minus 1, 4. F of 5 minus 2, 3. Means f of 4 plus f of 3. Here f of 4 is 3 value. F of 3 is 2 value. Then here 3 plus 2 is 5. The value of 3 plus 2 is 5. Okay, f of 0, 0. F of 1, 1. F of 2, 0 plus 1, 1. F of 3, 1 plus f of 3 is 1 plus 1, 2. F of 4, 2 plus 3, 3. Then f of 4, 3 plus 2, 5. Then if you want to take f of 6, that will be last two values will become, that is 8. So like that we can calculate the values. Okay. Then up to I less than n. Then here I is equal to 2 successfully executed. I is equal to 2 is successfully executed. Then I is equal to 3 less than 5. That will be executed. Then next 4 less than or equal to 5. Successfully executed. Then 5 less than or equal to 5. Successfully executed. When it will become 6, it will become fail. Then you will get the value of these. Okay. The same concept. This is very simple. No need to any recursion. No need to any recursion. Then here in memoization, we are using the recursion. In tabulation, just we are using arrays, no recursion. No recursion. Just we can recall these things. These are the values of, these are the concepts of memoization and tabulation mechanism. Just recursively, we need to call the things. If it is already calculated, no need to calculate again and again. This is the advantage of dynamic programming. Hope you are understanding about the dynamic programming. The example is Fibonacci sequence we took. Then next we need to solve some knapsack problem and shortest path algorithms we will solve in next classes. Hope you are understanding the main important things are reducing the time complexity, efficient for recursive problems. The computes calculates only required subproblems, improve the performance significantly, simple to implement. Then what is an applications of dynamic programming? The applications of dynamic programming, pathfinding, finding the path, source to destination, resource allocations, allocation of resources, machine learning optimization problems, natural language processing. We need to perform on text and image processing. Then these are the main applications of dynamic programming. These all applications we are using memoization concept and tabulation mechanisms. Then this is the concept of dynamic programming, memoization and tabulation, for example of Fibonacci sequence. I hope you understand this example. Thank you.